Hello everyone, I am Sri Raksha, student of SBCE from the Department of Computer Science and Engineering. Well, in this video, I am going to discuss about the subject mathematics. Topic vector calculus. The contents I am going to discuss are introduction, scalar and vector field, gradient of a scalar, directional derivative, divergence of a vector, curl of a vector, applications and conclusion. Let's see. Introduction. Vector is a quantity having two dimension and magnitude. Example, velocity and acceleration. What is vector calculus? A vector calculus is a branch of mathematics concerned with differentiation and integration of a vector field. It is a fundamental field that allows us to model a wide range of physical phenomena. Next one is scalar and vector field. Scalar field. The scalar field are the mathematical entities that assign a scalar value to each point in a space. For example, if every points x, y, z of a region are in a space, then they correspond a scalar phi of x, y, z. Then phi is called as a scalar points function and its scalar field is phi defined in region R. Next one is vector fields. Vector fields assign a vector to each point in space. For example, if every point xyz of a region R in a space, they corresponds to a vector field A is called as vector point function and vector field A is defined in region R. Next one is gradient of a scalar. The gradient of a scalar field is a vector that points in the direction of maximum increase of the scalar field. The formula to calculate the gradient of a scalar field is dou phi by dou x I cap plus dou phi by dou y j cap plus dou phi by dou z k cap. Applications of a gradient of a scalar field. The gradient of a scalar field is essential in physics. It describes the flow of heat, fluid, and many other physical phenomena. In electromagnetism, the electric field is the gradient of the electric potential, while the magnetic field is the curl of vector potential. Next one is directional derivative. What is directional derivative? The directional derivative of a vector field is the measure of how the field changes in a specific direction. It is a number or a vector depending on the function and the direction chosen. The directional derivative is defined in terms of partial derivative. It can also be calculated using a dot product or using a gradient of a scalar field. Next one is divergence of a vector. What is divergence? Divergence is a measure of the degree to which a vector field flow outward from a small region. It also defined as a dot product of a del operation and the vector and its scale and it is a scalar quantity. Applications. The divergence theorem is an essential tool in mathematics, allowing us to relate surface integrals to volume integrals. Next one is the curl of a vector. What is curl? The curl of a vector field is a measure of degree to which it circulates or spins around a point. It is a vector quantity and it is defined as the cross product of the del operation and the vector field. The curl and the gradient. There is an important estimate relationship between the curl and the gradient. If the curl of a vector is 0, then there exists a scalar potential for the field, meaning the field can be written as a gradient of the scalar field. Applications. The curl has important application in electromagnetism, fluid mechanics, and other field where the rotation is important. Applications of vector calculus. First one is geometrical description of the world. Vector calculus provide a powerful tool for dealing with the complexity of the natural world. It helps us describing from everything of the planets to the flow of viscous fluid and the behavior of electromagnetic fields. Next application is data analysis and visualization. In data science, vector calculus allow us to analyze complex data sets and visualize them in meaningful ways. It used for machine learning, which is growing in important as much as more data is being generated every day. Next one is engineering and 3D printing. Vector calculus is used extensively in engineering and manufacturing. For example, it used to create 3D models and to determine the stress and strains in complex structures and ensure they will be safe and reliable. Conclusion. Vector calculus. As its core, vector calculus is a powerful tool to analyze the complex systems in three dimensions. Applications. From fluid mechanics to computer graphics, vector calculus find important applications in wide range of fields. Endless possibilities. The potential for new developments and discovering in vector calculus is truly limitless. Thank you for watching my video. Please do like,